Now all the international fans will rejoice in glory that is your answer. How do we solve this? Adding? What are we adding?
The like terms.
You said the right terms?
The like terms.
The like terms. Okay. You wanna flesh that out some?
No.
Alright, so having started this off, anyone wanna pick that up or say, you know what, I got a better way, but the feng shui of this is that we need to solve it differently. I would like to suggest let's simplify, let's combine like terms as the first step, no matter what technique you're gonna use. And I would also suggest let's get it so that we line up the variables, put the constants on another side. I think that's beneficial regardless of the technique. So, well, we got the first one done. And what's the next one?
So we move the constants to one side and line up the others, right?
Okay.
So we'd have, I don't have a D in there, do we? No, so. We'd have, sorry,
Negative 5e plus 6f equals 2.
All right. And, well, wait, never mind. And next.
Negative 70 plus 5e equals 22.
negative 22?
Negative 22.
All right, so we've provided some order here for some of us. It just feels like a more manageable problem. Now we have to really decide what math technique we're going to use. So, what math technique we're going to use? The three that we've done in class are substitution, solving simultaneously, Cramer's rule. There are other techniques, those are just the three that I've done.
Kramer.
I heard Cramer's rule, okay. So Kramer's rule, we're setting up a bunch of fractions here. At least the denominators are all the same. So we're doing the determinants. What do I fill in here?
-5 and +5.
Say that again?
Would you put the -5 and the +5?
Where would I put those?
In the top?
All right, when you're doing Kramer's rule, the denominator is using these, the numerator is gonna bring this into it.
Okay.
So, we need to put the coefficients in order. So the first row, the coefficients of the first equation.
Oh, I was looking at -7.
Oh, you wanna do the last one first?
Yeah.
Okay. -7.
5. 0.
Okay. Now, I could have put that first, the reason I didn't is because I've written it in this order for me, I need to make sure that these are in the same order, so if I put that as the first row, then that's gonna have to pop up to the top for the numerator, and I was just keeping it simple for me.
0, -5, 6.
Okay?
0 would be 1.
1.
1 and 1.
All right. Do a quick check, making sure it matches up. Yep, we're good. So solving this one, do you want to do it the classic determinant way, or do you want to do the shortcut?
Shortcut.
All right, so I'm going to repeat the first rows, or first two columns. 1, -5, 5. So I multiply those together. So 0. And multiply those together. Plus -42. And multiply those together. Plus 0. Minus. Multiply those together. 0. Those. Plus 30. And those plus 35. So let's see, that's -42 minus 65, or -107. A minus sign in the wrong spot will mess the whole thing up. But don't think we've made that mistake. All right, so what's the numerator? You'll have to be louder.
0, 2, and 22.
0, where am I putting the 0, 2, and -22?
Down.
All right, so when D, is that the first, second, or third variable?
First.
Okay, so I'm gonna replace the first column with the 0, 2, -22. The next two columns are the exact same. And just for fun, let's do it the old-fashioned way. So 0, times -5,650 minus 1, and I'm left with 2, 6, -22, 0, plus 1 times 2, -5, -22, 5. Dramatic pause for people to catch up or ask questions. So this will end up being 0 times 0 minus 30. Minus 1 times 0 minus 132 plus 1 times 10 minus 110. Which is -30 plus 132 minus 100, which is 2. So we end up with 2 over -107. I feel like that is not what we had before, when we did it the other way. What answer did we have before?
86.
For it'd be the current flowing across the 3 or the 4 ohm resistor.
The current was 232 over 107, and the direction was to the left.
To the left across 3?
Yeah.
So left across 3 and right across 4. All right. So I feel like, well, there's one problem. That's 0. That's -30, but times 0 is 0. All right, let's make sure I didn't lose a minus sign somewhere. 160, 122, and then 0 to -22. So I did 0 times that, 1 times, so 26, so that'd be 132, and then we had 232.
Yeah.
So either we made a mistake before, or we made a mistake this time. I feel like a denominator is right, because -22, that's 10. 5 times 20 is 100, times 2 is 10, so that would be, sorry. This is so many places to make a gamma's error. Oh, no, that is right, never mind. Well, let's keep going, and then we'll check our answers, see if this was right or what we did before was right. All right, so E. I know the denominator. It's going to be -107. the numerator. We're now trying to solve for what's listed as the second variable, so we replace that second column. So what's my array? Like what is my array gonna look?
Zero, negative 5, 5,
So
going down.
going down. What is this again?
0.
You said 0, negative 5, 5.
1.
All right, start again.
1,
1,
negative 5.
all right, so when you're figuring out the numerator, this is sort of the starting point, and then you replace the column with the constants. So if I'm solving for the first variable, I replace the first column. If I'm solving for the second variable, I replace the second column. And these two stay the same. For the third variable, I replace this column and leave these two as is.
Okay, so then 1, 0, negative 7.
Okay, 1, 0, negative 7.
0, 2, negative 22. And 1, 6, 0.
1, 6,
Yes.
0. It's 1, 0, negative 7, 0, 0, 2, negative 22. And so we end up with 0 plus 0 plus 0 minus negative 14 plus negative 132 plus 0, which is negative, it'll be a positive 146 over 107. So what did we get as the current flowing across the 5 ohm resistor before?
146 over 107. Yeah.
Okay, and the reason we got it positive before is we had the current going down before, and we got a negative because we've said E was going on. All right, so that's looking right. Put it in a more traditional form, 146 over negative 146 over 107 amperes, basically going up, or 146 over 107 amperes going down. And then D. We did D. F. Negative 107. And what is my numerator gonna look like? What is the array?
One.
0,
Okay.
1, 0, negative 7. 1, negative 5, 5. 0, 2, negative 12, 0.
All right. 1, 0, negative 7, 1, negative 5, 5. All right, so multiplying that diagonal, I have 110 plus negative 14 plus 0 minus 0 plus 10 plus 0 over negative 107. So I have 96 minus 10, so I have 86, negative 86 over 107 amperes. Basically going that way. And what did we get before?
86 over 107.
All right, so we've solved it, and the nice thing about Kramer's rule is that if I messed up on D, that doesn't necessarily mean that E and F are wrong. Whereas the other methods, once you get, if one of them's wrong, then it's gonna propagate. We can check to see if our answers make any sense by plugging into an equation. If all three of these are correct, then we should be able to plug in. So if I do D plus E plus F, do I get 0? Well, I had negative 32 over 107 plus E, negative 146 over 107 plus F, negative 86 over 107. And that does not add up to 0. So there's got to be a mistake here on D, based upon the fact that that's what we had. We had a different answer before. So let me take a look at this again. So we had 1, negative 5. So 1, negative 5, 5. 1, 6, 0. Good with that. And then 0 to negative 22. I did 0, and I'm left with negative 5, 6, 5, 0, minus 1, and I'm left with 2, 6, negative 22, 0, plus 1, left with 2, negative 5, negative 22, 5. All right, that looks like it's written correctly. That's 0 minus 30. That's 0 minus 132. Ah, no. Yes, there's the mistake. It's 0 minus negative 132.